Now for this one here, they're asking us to the air pressure. This is problems chapter 6, section 2, problem 8. Air pressure can be modeled by the exponential equation y is equal to 14.7 times E raised to the negative 0.0431 times x, where x represents altitude in thousands of feet, and y is air pressure. Complete parts A through E below. What is the continuous decay rate in this case here? They give us a little hint. They're talking about K, so they want to know what the K is in this particular equation. In this particular equation here, the K is a negative 0.0431. So when they refer to here that it has a negative on it, they take the negative off of it and say decreases at. They don't say minus, they say decreasing at 4.31%. Then they want the decay rate for every 1,000 feet, not continuous. They give you a hint here. So K is continuous, R is the annual decay per year. For every 1,000 feet. So we know that e to the k is equal to 1 plus r, and we know how to find e to the k. We can plug that into our calculators and find that to be 0.9578. So r would be 0.9578 minus 1. From there we can see that we can identify what r is going to be. R is a negative 0.0422. So we know what r is. There, subtracting 1 from both sides, you get your r. They want it as a percent, it'd be a negative 4.22%. Then the C right here. So they don't, when they decay rate, they don't say minus, they just say decaying or decreasing at a particular percent rate. Then they want here to write an equation in this form. So we have the original equation, and they want it in this form. We already found what e to the k is. E to the k, we found that to be 0.9578. P0 is 14.7. So now we have our equation. We have our equation. They want to know the air pressure at 35,000 feet. X represents the air pressure in thousands of feet. So x equal 5 will represent 5,000 feet. In this case here, x represents 35 or 35,000 feet. So when we plug in here to find the air pressure, replace x with 35. We simplify it. We have 0.95 to the 35th power times 14.7. Gives me 3.25 psi. Then they ask for the air pressure at sea level. At sea level, the altitude is 0. And anything to the 0 power is equal to 1. So I'm going to have 14.7 times 1, which is 14.7 psi. That's how you approach that problem there.